Good morning. Good morning, everybody. It's nice to see you. I hope you can hear me. Okay, so thank you very much. My name is Simone Severini. I'm going to share this section of the seminar, which is focused on risk and risk management. Just information, we had three papers to present, but unfortunately one presenter cannot attend, and so we will have the section for presenting two papers. The first one is the drivers of EU region expenditure on risk management toolkit of the CAP, and I believe it's Kafaji presenting the paper. And then we will shift to the economic risk assessment of the quality label and productive efficient strategies in Spanish extensive sheep farms, a paper presented by Daniele Bertolozzi Caredio. And so we'll have the opportunity to discuss on one side the risk assessment of a specific case study, and then some insight about the risk management tools that can be applied. And so quite different paper, but on the same topic, risk and risk management. Okay, I see there are 27 viewers. I'm happy about this and I welcome them. I think we can leave the floor directly to for his presentation, and we have plenty of time, so you can keep your presentation within 20 minutes, so we will have 10 minutes for discussion.
Thank you very much. Thank you very much, Simone. Can you see my PowerPoint, my screen?
Not yet, yes.
Okay, perfect. Thank you. So I will present our paper on the drivers of EU regions expenditure on risk management toolkit of the CAP. It's co-authored with Mauro Vigani and Robert Berry from the University of Gloucestershire, and it was part of Sure Farm project. Just a brief introduction. We have the CAP, or the Common Agricultural Policy in the EU policy, which provides farmers with overall income support. But since the CAP reform in 2013, there were new measures for risk management, which could be, which is part of the Pillar 2 or the Rural Development Program, and it can be adopted voluntarily by EU member states or the regions, EU regions. These two measures are comes in Measure 5, which is to restore agricultural production damaged by natural disasters or catastrophic events, and the Measure 17, which is targeting risk management tools. Specifically, Measure 5 aims to provide financial contributions and for investments that can restore agricultural production damaged by natural disastrous events. And Measure 17 has two components. The first one is to support farmers with insurance premiums and mutual funds, which can then help them to cover losses caused by climate changes or diseases or other environmental incidents. And the second component is to provide support for mutual funds that can compensate farmers facing severe drop in their income. So that can be also related to market risks. So not just environmental risks, but also for market risks. This is commonly known as income stabilization tool. And Measure 5 and Measure 17 are both known as the risk management toolkit of the CAP. We have 200 from our data, from the empirical data. We have 230 regions NUTS at the third level, NUTS 3 regions in the EU in 13 countries who have already allocated funds for the risk management toolkit. So the aim of our paper was to understand why some EU regions have allocated these funds and based on what factors, and why other regions did not adopted the risk management toolkit or spend less from the toolkit. We assume that there would, or we hypothesized that, sorry, we assume that there will be four factors or four main factors. The first is risk factors from environmental risks like soil erosion by wind or water. Others is environmental factors that affects the land cover or geographical factors. In addition to main economic factors like the share of agricultural sector in the economy, the share of total cap support in the agricultural value added of the region, and in addition to, we tried to capture political and institutional factors at the NUTS 3 through adopting spatial analysis. We used data from the CATS dataset, which is the real expenditure of NUTS 3 regions, EU NUTS 3 regions. We used we used 4 years averages from 2015 to 2018, and our main variable is risk management expenditure, which is the sum of measure 5 and measure 17 as percentage of the pillar 2, or as percentage of the rural development program. So we wanted to understand why some regions allocated this amount of money, or this percentage, this share of money from the rural development program to the risk management. The main factors that we were anticipating were risk measurements, like the soil erosion by wind and soil erosion by water, data from the GRC, and land cover from like arable land, percentage of arable land from the total area of the region, permanent crops, pastures, land, heterogeneous agriculture, and forests. We also have land least favorite areas, which is not in the slide, but we also have the percentage area of least favorite areas, so disadvantaged areas and mountains, etc. The other variables are to control for the cap subsidies as percentage of agricultural value added, the size of agricultural sector in the economy, per capita income, and a country dummy variable to control for other country effects. As I said, all data are at the NUTS 3, at the third level, regional data, and all variables are locked and transformed. So we have mainly two methods or two methods that we have adopted. First was to test for spatial dependency using Moran's I statistic, and this is just to tell us if there is a spatial correlation, or if there is a spatial factors that actually explain the expenditure, other than the factors that we other than the variables that, or the factors that we include in the model. If this is the case, then we applied a spatial autoregressive models, and mainly, or what I will report today is the spatial Durbin model, which is the most common model, and spatial Durbin error model. The spatial Durbin model is important because it reports three main things. First, it reports the I'm sorry, Simone, we can't see my mouse, right? Okay. So it reports the normal beta or the normal uh, uh, explanatory factors, explanatory variables on the dependent variable, but it also report the lag dependent variable, which is the neighboring or other regions risk management expenditure and its effect on the expenditure of the underlying region. In addition, it also reports the explanatory variables or the factors of the neighboring region and its effect on the underlying region. So if we have region I, we want to measure the expenditure in region I. We have the normal or normal independent or explanatory variables of region I that affects the risk management, but also we have the risk management expenditure of the neighboring regions in addition to the risk factors and environmental factors in the neighboring regions. The spatial Durbin error model is the same, but instead of the neighboring risk management expenditure, it just account for the autoregressive error terms. So just tell us if there is a spatial dependency or not, but doesn't really explain more. The first step was to test for spatial dependency in the first uh, incident using Moran I statistic, which tells us if there is spatial correlation in general. It doesn't tell us more than that, but it's a very important step. And here we have 0. Almost zero point 0.6 Moran's I statistic, which is positive and it tells us there is a spatial dependency. The next step or a better understanding of the nature or the effect of this spatial dependency is to get the significance map on the left side and the cluster map on the right side. The significance map on the left side tells us the significance or the level of this spatial correlation. The dark green areas is the most significant is where regions where most significant spatial dependency are, and then the light green is less, and the blank or the white regions is where there is no spatial dependency at all. The cluster map tells us more how the clustering of the risk management measures or expenditure, in the sense that we can have high regions, which is a region that has a high risk management expenditure, surrounded by other regions that have high risk management expenditure. They are very few, but we have 20 regions like this. And then the low, which tells us if regions with low risk management expenditure are surrounded by other regions with low risk management expenditure. These are very high number, which is 171 regions. And then the and then we have low, high, and high, low, which are uh, like the opposite. So regions with high risk management expenditure surrounded with low risk management expenditure. The important or interesting part of thing in the cluster map is that it shows that there is clustering effect, or that there is a clustering pattern in the expenditures of risk management toolkit, and that there is also spillover or can indicate a spillover that when there is a neighboring, especially the high and low, or the dark red and dark blue regions, which tells us that if the neighboring region is spending high or low, then there is a high probability that the underlying region is also spending more or less on the risk management. The second step is to, as I mentioned, was to do the regression itself, the spatial autoregressive regressions. We report first the interesting part first is to report the ordinary least square, the OLS. And why it is interesting is because if we did not account for spatial dependency, we will find that soil erosion has a negative, statistically negative effect on or explanation of the risk management toolkit, which is very surprising. But if we account it, but because we have spatial dependency, which explains more, then the significance disappears. So in reality, which is surprising still, that risk factors like soil erosion by wind or water doesn't have any effect on the allocation of risk management expenditures. The important part to focus on this table slide is the rho and the lambda here. Here, the rho is just to show the extent or the high extent and high significance extent of the spillover effect in risk management allocation. So we have rho and lambda explains much the highest effect of this spillover, that the spatial dependency or spatial clustering explains a lot of the decisions to allocate risk management expenditure. The other factors will be better explained in this table, which has three main. So both sides are the SDM and the SDM are the same. So I will just focus on the SDM, which has three main columns. The direct column explains the effect of these factors or these variables on the underlying region. So on my region, for example. The indirect effects explains the effect of these factors of the neighboring region on my region or on the I's region. And then we have the total effect of both. So we have first thing we have that least favorite areas with mountains and disadvantaged areas have high. There is a probability of having higher risk management expenditure. This is an interesting result. The second is that there is more concentration in arable sector, and of the so if the region is have high share of the land is in arable farming, then there is a high probability that it will have high risk management expenditure. And interestingly, again, that the cap subsidies, so regions where there is a high, large amount of cap subsidies as percentage of the total agricultural value added, spend less on risk management toolkit. And then from neighboring regions, permanent crops and heterogeneous agriculture seems to have negative effect on the underlying region's expenditure. So we can summarize these results on the following. First part is that there is a strong spatial dependency on the level of risk management expenditure. This that one region is positively dependent on the neighboring region's expenditures. There are regional clusters of these expenditures across the EU. There is higher expenditures in land in mountains and disadvantaged areas, as well as arable farming. Neighboring land use affects the region's risk management expenditure, specifically permanent crops and heterogeneous agriculture. And EU regions receiving large amount of CAP subsidies relative to the size of their agriculture tend to spend less. We conclude that, so from that we can conclude that first, risk management policies follow a territorial spatial pattern. So it's not adopted in isolation, rather it is adopted through national policies or mutual influences, institutional or political factors that affects the regions. Only the arable sector is in more need of risk management policies than other sectors, as well as these favorite areas, as we mentioned. Finally, direct CAP payments and other RD and other rural development measures seems to be also providing income stability and sufficient liquidity to deal with unexpected damages. So there is either a substitute effect from the cap, from the total cap support, which is regions that receives higher amount of cap support does not seem to need to spend more on the risk management toolkit, because the cap already provide income stabilization and sufficient liquidity for farmers. Or it can be, again, because of a political or budget decision on the national or the regional level. Thank you.
Thank you very much, Amr, for your interesting presentation. It's a very nice, also the coverage of the study at the EU level is very interesting. So I think there are 40 viewers right now, and I don't know if there are questions. I will ask to attenders to pose questions on this presentation. In the meantime, I just have a few comments. The first one is, of course, this kind of tools are very useful to cope with shocks coming from weather conditions. Okay, so for example, insurance are very useful to cover for risk of hail or of spring frost or drought or heat waves. So maybe other than just soil erosion, you may try to include variables such this one. While there are no questions, another one is maybe, of course, this is very interesting, very nice study covering the whole EU level, but of course, in this case, you assume that the relationship between some of the control variables and the level of use of risk management toolkit expenditure is the same in all areas, in all countries. So maybe, if it's possible, I don't know if you have enough degree of freedom, you may try to split the sample and to try to do different estimation to see if the parameter you estimate remain the same according to the regions. So I think, yeah, if you can answer or comment on these suggestions, please.
Okay, thank you so much, Simona. This is very interesting. I mean, the first point, because it's also limited, we have limited variables on the level 3. So I thought to work on level 3, NUTS 3, to get more detailed answers, but that was on the expense of getting variables on the NUTS 3.
Yes.
And so finding other environmental or other risk measures was very difficult. The second point is very interesting. I would actually, it's very good advice. So I would like to split the data for the EU regions, and I think it would be interesting results.
Good. In the meantime, we got one question, which is, by Murilo de Almeida Furtado. Is it possible to relate payments with specific shocks? Again, is it possible to relate payments with specific shocks?
Not in this analysis, not in the analysis that we have done, but I'm just thinking, yeah.
No, I believe the data you have are very aggregate. I know this CATS data, and it's not possible to do. It's a very aggregate data.
It is, yeah. I think it's the most detailed thing is at the NUTS 3, but I don't think we can do that because also the risk part. So the risk, the soil erosion, for example, soil erosion variables does not come at yearly. I think it's not continuous data, so it is difficult to really measure if there is a specific shock caused an increase.
Yes, I'm not sure if I got exactly the question right, but I have an additional question, which is you say that you are working at NUT 3, okay,
Yes.
but for example, in Italy, I'm sure that the policy is managed at the NUT 2 level. So our region, we have, for example, 21 region in Italy, you know.
Yes.
So I don't know if this is also maybe causing some sort of spatial correlation. I mean, if one region step in, for example, increase the amount of expenditure, of course, this is going to expand for all the different NUT 3 areas. Maybe you want to check for this.
Definitely, yes. I think it is one of the limitation, but because what I know that different EU member states adopt different strategy to the allocation of the caps. So
Absolutely.
in Italy it's NUTS 3, but other regions might be using NUTS 2. So
Exactly. In Italy, it's not 2. That's how I'm saying. So if the analysis is not 3, you may find clearly some correlation, special correlation between the NUT 3 belonging to the same NUT 2 unit.
Yes.
But this is, and another reason for splitting different countries could be that, you know, in some regions, like in Germany, for example, there is a quite strong use of private insurance. So the supported insurance are not so common, you know, while in Italy or Spain, it's very much supported. Well, in Spain, you know, also the system is different, but that could be interesting, I believe.
Yeah. Thank you. Yes. Thank you.
Okay, no more question, please. You have 1 minute more for posing questions. Okay, so no additional question. I'm very much happy about your presentation and work. So congratulations and keep going on this. Thank you,
Thank you.
So now we leave the floor to Daniele Bertolozzi Caredi, I believe is presenting, and is presenting a paper on economic risk assessment of the quality label and productive efficiency strategies in Spain, in Spanish extensive sheep farms. Thank you very much. We cannot hear you, Daniele. I don't know if this is a technical problem or... Okay.
Yes, it was me. It was muted. Can you hear me now?
Yes.
It's fine. Can you see the presentation?
Yes.
Yes, perfect. Thank you, Simone. And thank you, Am, for the nice presentation. And this is very more specific research that is focused on specific on-farm strategies in extensive sheep farms to face specific risks. And is carried out by Barbara Soriano, Isabel Bardacchia, and Alberto Garrido with me, and within the Sure Farm project. And is focused on an extensive sheep farming system in Aragon northeast Spain, that consists of small, medium family farms that rely their production on high extension of not only land and family labor and a flock of average 700 heads, but it can range between 200 and 1,000 heads. And they are oriented to lamb production, not dairy. But traditionally they can be coupled with almonds and olive orchards and cereal production where they are located in flat areas. Why they are important? Why this system is important? Well, they are located, these sheep farms, mainly in marginal and mountain areas where other kinds of agricultural activities will be unviable or less viable. And so here they provide a number of socioeconomic functions and ecosystem services, such as maintaining rural population, cultural heritage and landscape, conserving biodiversity and natural resources, or prevent wildfires and carbon sequestration. Now, so the concern is that probably this activity, this agricultural activity, is the only one able to provide such services and function in these areas, while other systems do not. What is the problem with this system? Well, in the last couple of decades, there has been a serious trend, decreasing trends in the number of farms and sheep in the region. You can see that there has been a drop by 25% of sheep farms between 2013 and 2019, and a drop of 40% of heads between 2006 and 2018. And in addition to this, there is a shortage of workers and successors willing to enter the sector, and there is a broad transition of extensive sheep farms to intensive productions like intensive sheep, intensive pig production, and intensive crop production where they are located in irrigated flat areas. What are the reasons behind these trends? Well, there multi-stakeholder focus groups was held in 2019 in the area, and the participants stated that the main reason is the structural low profitability of extensive sheep farms. And the factors leading to the low profitability, in their opinion, were the increasing feeding cost and low lamb prices, the sharp reduction of lamb meat consumption in Spain, that is very impressive. The per capita consumption of lamb in Spain has halved in less than 1 decade. The significant reduction of couple subsidies in the last decades due to the CAP reforms, and more recently, increasing environmental risk, such as new diseases for sheep. There are a couple of new diseases affecting sheep, drought that appear to be more intense in the last decade, and a growing phenomenon of wolves attacks. So, how to deal with these trends? Another focus group held in the region, multi-stakeholder focus groups, highlighted two main way out to deal with these challenges. On the one hand, a demand-oriented strategy based on quality production and mainly on the use of a labeling strategy, mainly protected geographical identification strategy. And on the other hand, a productive efficiency strategy, mainly based on the increased prolificacy of sheep, where for prolificacy we mean the number of lambs born by each iwi, the female sheep, in a year, net of abortion. That is the crucial point, the crucial element of lamb production. So, what do we want to do with this research? Our objectives are overall to evaluate the economic performance and risk of these two alternative demand-oriented and productive efficiency strategies and specifically, first, to compare the current economic performance and vulnerability of conventional production that we call baseline scenario, an increased polyefficacy strategy, a protected geographical identification labeling, and a joint strategy joining integrated efficiency and quality production. And second, we want to evaluate the above scenarios under two economic risks: decreased land prices and increased feeding costs. How to do that? Well, we drawn a land production gross margin model, as you can see. The square in the middle of the figure, there is the baseline scenario, the conventional production. Its core, so is the lamb production, I mean, the number of lambs born by each iwi, that is called the prolificacy rate. The lamb production has two specific costs: feeding cost and sanitary cost per iwi, but they include the cost of lamb before being sold. And then this lamb result in a gross margin depending on the lamb price, conventional lamb price in the market, that usually is the national Spanish market, but to a lesser extent it could be exported to other countries such as Arab countries. And it also, the gross margin also relying on a coupled subside per iwi. Then on the left we can see the two main risk factors, as mentioned, as highlighted by the stakeholders in the region, that are increasing feeding costs and decreased land prices. And on the right, we can see alternative strategic scenarios. First, an efficiency scenarios, so hypothesizing increased prolificacy, and indeed this is based on a survey on 54 surveys collected in some specific municipalities of Aragon, of the region, in which sheep farms showed much higher prolificacy, so much higher efficiency. So with this scenario, we want to answer the question, what would be if in all Aragon sheep farms was as efficient as in these specific municipalities? And then another scenario that we want to test is a quality scenario that is based on the use of a protected geographical identification label, specifically Ternasco de Aragon, is the only available label in Aragon for lamb, and of course is based on different prices that usually are higher. And so we designed a simple gross margin model, as you can see, that is based on prolificacy rate and price that gives a revenue, and specific costs are feeding cost and sanitary cost. And we also account for the coupled subside. We also take into consideration that feeding cost would increase with increasing prolificacy, with this conditional equation here. And our gross margin model is based on data from the Spanish Farm Accountancy Data Network that provide us with data on cost and subsidies, and for 230 farms between 2014 and 2017. The Spanish Ministry of Agriculture provide information on prices and the regional average of prolificacy in the period 2004-2017. And we have, as I said, more specific information, improved prolificacy from 54 surveys of farmers. And then why we choose this model? We could include, of course, more information on the model. But for example, about cost, we can see from this graph that feeding cost is this graph shows the decomposition of cost, of all cost in the sheep farm business in Aragon. And we can see that feeding cost is the highest one, clearly the highest one, while, for example, leasing costs of land and salaries are not so significant. You can also see that sanitary costs are not significant, but we wanted to include it because, as we said, there are an increasing concern about diseases. So we were curious, interested about analyzing this cost. General cost, well, it's relevant, 24%, but we didn't include it because it's based on fixed assets of the farms that is very different between farms. And so it's very different. It's very hard to compare farms between each other based on fixed assets. So in fixed capital. So we didn't include general cost. And here we can also see some trend about prices, feeding cost, and sanitary cost. We see that conventional prices, the green line, it seems quite stable, while the protected geographic identification label prices are general overall, this seems higher but more variable. In feeding costs seems increasing, appears increasing, even if there is a drop in 2015. And about sanitary costs, there don't seem to be high variability, and they seems quite stable and not, as we saw before, not so significant. However, what we want to measure with this model? Well, we want to measure the economic performance as the average gross margin, and we want also to see the vulnerability of these strategies through the use of some risk indexes. These are the most common indexes probably used in this kind of risk assessment analysis. So the distribution moments and other risk index, for example, kurtosis skewness and the standard deviation. But we also consider risk indexes like coefficient of variance and the semi-coefficient of variance, where coefficient of variance is the share between the standard deviation and the mean value and the average value of the distribution. And semi-coefficient is of variance is the coefficient of variance of the left side of the distribution of values, the downside risk. Value at risk, we measure it as the share between the difference between the mean and the 5 percentile shared with the mean value of the distribution. And the break-even probability is the probability to get a positive outcome, a positive output in the model, so a positive gross margin. It is expressed in percentage. How do we analyze it? Well, first of all, we based our analysis on Monte Carlo simulation. And as you can see, our model that should be before, the variables in the models are all stochastic variables. So we consider the variability of all the variables. So first of all, we perform stochastic simulation under no stress of the 4 strategies, and to measure the above mentioned indexes. Second, we also performed the sensitivity analysis to see which factors contribute the most to the variability of the model, and we used a couple of approach. First, an input regression coefficient approach, and second, a regression mapped values approach. Then we try to test these strategies under 2 specific stress, the feeding cost and price. How did we stress this variable? Well, we limited in the stochastic simulation, we limited their distribution to the 50 and 10 percentile. Respectively, in feeding cost, we limited the probability distribution to the 2 levels, to the highest levels, so 50, the highest 50 percentile and 10 percentile, to simulate the highest feeding cost possible based on our actual data. And the same way we did for prices, but in this case we simulated the lowest 50 percentile and 10 percentile. And after that, we also wanted to measure the sensitivity of the model to decoupled subsidies. So to approach this analysis, we we reduced coupled subsidies at 5 reference level, as you see. So base outcome, no change, minus 25, minus 50%, minus 75%, and then complete removal. And we ran the model for each of these reference level to see what happens by reducing coupled subsidies. So what did we find? These are the results of the Monte Carlo simulation of strategic scenarios under no stress. You can see a table with the 4 scenarios on the rows and the gross margin mean and the various risk indexes. And then you can see a graph with the probability distributions of these simulations. Looking at the graph, we can see a relevant difference between strategies, above all between the efficient in joint scenarios and quality in baseline scenarios on the other hand. In fact, if we see the table, you can see that there is very impressive increase in the average gross margin with efficiency in joint scenarios. But we also see that the standard deviation and the semi-standard deviation are higher than they are in the baseline and quality scenarios. And in fact, if we look at some risk indexes, for example, coefficient and semi-coefficient of variance and the value at risk, they reduce under efficiency in joint scenarios, but the degree of their reduction is not as impressive as the increase in the gross margin, average gross margin. And we can also see, comparing the quality scenario with the baseline scenario, well, there is a low improvement in average gross margin, about 3.5 euro. But we can also see that the risk indexes are slightly higher, so indicating that this strategy could be more vulnerable. Then we can see the sensitivity analysis to see what variables impact the most in the variability of the model. So we have top right we measured the sensitivity analysis by using regression coefficients. These take into account the relative contribution of a variable with respect to the gross margin by regressing the gross margin on the different variables. And the bottom left, we use another approach. We quantify the change in gross margin, euro change in gross margin, for each standard deviation change in each variable. So this gives evaluation in euro of the potential impact in the model of the variables. And we can see that feeding cost is the main source of variability in the model, followed by improved pro-efficacy. But we can also see that can be interesting that the PGI price, the label price, is more impact the most on the variability of the model with respect to the conventional price. After that, we see the results of the strategic scenarios under price and feeding cost stress. So here we can see the table with the 4 scenarios, and on the rows we can see the stress, then price stress, feeding cost stress, and simultaneous stress by 10 percentile and 50 percentile. And what we can see? We can see, first of all, that under price stress, this is interesting, the quality scenarios shows a higher percentage loss in gross margin, almost double it with respect to the baseline scenarios, so with respect to conventional prices. And in fact, the performance in terms of gross margin is similar between the two. And we can also see that the efficiency scenario is, of course, perform much better in terms of average gross margin, but however, the percentage loss is similar to the baseline scenario. Then we can see that the feeding cost stress is, in any case, in all the scenarios, the most impacting factor, causing very impressive, very severe losses, percentage losses. This is much more evident in the baseline and quality scenarios, in which we can see that the break-even probability, for example, in the case of 10 percentile stress, is very low. And this is interesting because we are using a gross margin model, which we are not taking into account, as we said before, the general cost. So this impact could be even more serious in the case of some farms that has very high general cost. We can see also that the impact is relevant in the efficiency in joint scenarios, but for example, the joint scenario that merge quality and efficiency strategies is the one that performs the best under feeding cost stress. And obviously, the simultaneous stress show the highest losses. But here we can see that efficiency and joint strategies perform better. And then what about the model sensitivity to reduction of coupled subsidies? And here we see that by reducing the coupled subsidies in the model, there are, of course, losses ranging from 4%, 25%, depending on the degree of reduction and the strategies. But we can see that under efficiency in joint scenarios, this reduction is less evident, or at least is less important. This is clear also by looking at the complete removal, so the removal of 100% of the corporate subsidies. And there is a difference between efficiency strategies, for example, 70% of losses, and the baseline and quality scenarios that yields that losses about 23-25%. So here you can see the probability distribution of the 4 strategies under the 3 risks and stresses that we saw before. So under price stress, feeding cost stress, and simultaneous stress. And these graphs gives an idea of the difference between the strategies. And taking into account this information that we see so far, what are the key findings of this research? Well, first, feeding cost is the main source of risk in land production. Then the quality label strategy brings little economic improvements under no stress and is more vulnerable to price variability. Then the efficiency strategy performed the best, but with significant uncertainty around the average expected margin. And the farm dependence on corporate subsidies decreased importantly with increasing prolificacy. So based on these findings, what we concluded? Well, first of all, we concluded that quality labels shows low performance, and this could explain why the affiliation to the protected geographical identification Ternasco de Aragon has decreased importantly between 2008 and 2017. There's been a drop by 33% of registered farms in the label, and by 12% of the lambs sold under this label. And we found in the literature that a possible, but also in the opinion of the stakeholders, that a possible determinant is that there are few differences in farming practices between the conventional and the quality label production. This could be a reason why there is neither such a difference between the prices. But we also searched for opportunities in the strategies, and by looking at trends in consumption in Aragon and Spain, we found that probably opportunities for improving, for enhancing the quality label could be the growing purchase intention of Spanish consumers of meat products linked to grassland and extensive livestock, and also the increasing demand for easy-to-cook products. And we can see that farmer cooperatives in the region now are looking at these two opportunities for improving the impact of quality label in the market, and it could be very interesting. Then we also would like to suggest some points for future research. The one hand, we will need to investigate more which policies will successfully promote the adoption and marketing of quality label, but above all, investigating what factors are behind the variability of the price of the quality label, and also will be of interest to know if this variability regards also other quality labels on other regions. It could be a weakness of the strategy. Then about increased prolificacy, that we concluded that increased prolificacy is an effective strategy to reduce vulnerability and increase margin, but it's a strategy that requires time, innovation, and technologies, so resources. For example, two main approaches to get higher prolificacy are breed selection on the one hand and new, more innovative feeding systems on the other. And we saw that in the regions, the farmers are trying to reaching this goal, the increased prolificacy, through a collaboration between farmer cooperatives and research centers, local research centers, and it seems working. So this is a interesting indication also for other case studies. But we also see that this strategy does not ensure certainty over the expected income. There is a wide variability around the average gross margin. This could be due to year-by-year variability of prolificacy on farm, but also a high diversity between farms. So we conclude that maybe for sure is a strategy worth pursuing for the whole sector, to bring the whole sector on higher level of profitability, but maybe alone is not enough to ensure certainty of gross margin. And at last, we found that there could be potential in combining both strategies, above all when facing the increase in feeding cost. We saw that the joint strategies perform the best in that case. And so the suggestion here is to not look at these strategies as two alternative options, but as complementary strategies. Maybe this could be an improvement in the approach. And we suggest future research on the interplay between prolificacy and cooperative subsidies. We found much literature on the relation between efficiency and subsidies, but we didn't find, to our knowledge at least, specific studies about sheep prolificacy and subsidies, and this could be interesting to investigate in future. And at last, last suggestion where we saw that. Okay, I conclude. Feeding costs are the main source of risk. So the literature is highlighting how increasing droughts impact on feeding costs, and so will be interesting in future to investigate how climate change will impact in feeding cost in extensive livestock, or at least in sheep livestock. Okay, thanks for your attention. We concluded.
Thank you, Daniele. We ran a bit.
Yeah, I'm sorry.
I don't know if some of the viewers, we have 51 viewers, have questions. In the meantime, this is a very interesting analysis and very large. It's a micro base, but it's very huge in terms of different simulation, different strategies. So it's very challenging, I have to say, multidimensional, even if it seems, micro. So I have a question, which is the following. You mentioned that the quality scenario, it's not performing way better than the common one, okay? But what about the possible price stress? What I mean, I believe that maybe the price of quality lamb can be less prone to reduction in prices, so less affected than the normal lamb price. if there is a reduction in the common land price. So what I'm saying is maybe it's less prone to the negative impact of a negative market development. So maybe less risky than what is expected under price, worst price scenario.
Yeah, and this is, I think, the crucial point of the research about the quality strategy is the most interesting result. Well, yes, on the one hand, we also believe that the quality strategies could be a good way to get more stable, more solid price in the market, also on the long term. But we also saw that in this model there is a variability in this price, and this variability has impacted somehow in the model.
I mean, is it the same than the price of common land or not, the variability?
No, we use it two prices. So in the baseline scenario, we use the conventional light price in the conventional market, while in the quality scenarios, we use the actual price of the label in the last 15 years. So we are comparing these prices, and we see that yes, on average, the label prices are higher than the conventional prices, but there is more variability, and this is interesting because it raises a question, but is the quality strategy more risky? And we should investigate more this. We should understand if this is true also for other case studies, and we should also study what factors are behind this variability. But we also highlighted, as you saw, the some opportunities to get better prices in the market.
Okay, I'm asking to the administrator if we have to quit. I think we had to quit at 10, so I think we have to quit. Is it so? Okay, so I think, thank you, Daniele. I have many other questions on this because I've been working on similar issues and similar approach, but I will send you an email for additional questions.
That's fine. Perfect. Thank you.
Thank you very much, and very interesting presentations. Thank you very much to the attenders, and see you soon.